Microsoft has built a suite of technologies on top of its Azure infrastructure as a service. Today, we discuss Azure Stream Analytics, a real-time event processing engine developed at Microsoft. Azure Streaming allows for constant querying of incoming data streams, and my guest Santosh Balasubramanian discusses Azure and the movement from batch processing to stream processing. Before we get to this episode, I want to mention that Software Weekly is our newsletter that we put out every Sunday evening to condense what happened in the world of software, and you can sign up for Software Weekly or join our Slack community at softwareengineeringdaily.com. Software Engineering Daily is also looking for sponsors. So if you want to advertise your product on the show, or if you're looking for engineers for your company, Software Engineering Daily is a great place to get your messaging out there. Send me a message at softwareengineeringdaily@gmail.com if you're interested in that. After a quick message from today's sponsor, we will get to this episode. Podcasting full-time is a great career, but if I ever return to the normal world of work, Hired.com is where I will start my job hunt. Hired.com removes the frustration of searching for a job. You just fill out your profile and the jobs come to you. Facebook, Uber, and Stripe are a few of the companies that are hunting for engineers on Hired. Go to hired.com/SEDaily to try it out and get an extra $1,000 signing bonus just for using the URL for Software Engineering Daily listeners, which is hired.com/SEDaily. So if you want to try it out, go to hired.com/SEDaily. The demand for engineers is higher than the supply. And on Hired.com, that translates to higher salaries and happier careers for the engineers who find a job on Hired. I used Hired to find a job before I became a full-time podcaster. And the experience was so good because Hired connected me with a talent advocate who worked with me to find a job that was a good fit. And the talent advocate answered my questions about negotiating salary and finding remote work, which was something that was really important to me at the time. So check out hired.com/SEDaily and get a $1,000 signing bonus upon finding a job, which will be a great job that will give you the respect and the salary that you deserve as a great engineer. So check out hired.com/SEDaily. It would support the show. And now let's get on with today's episode of Software Engineering Daily. Azure Stream Analytics is a real-time event processing engine developed at Microsoft. Santosh Balasubramanian is a program manager for Azure Stream Analytics. Santosh, welcome to Software Engineering Daily.
Thank you very much, Jeff. How are you doing?
I'm doing great. So what is Azure Stream Analytics?
Azure Stream Analytics is a fully managed real-time stream processing solution that enables developers to get and businesses to get insights from their data in motion, their streaming data immediately. So if you want, I can give you some examples of what I mean.
Yeah, please.
So let's say you have a bunch of different sensors. Let's say we are doing some form of building monitoring. We actually have a customer called Honeywell that we just did case study with. What they did is they want to build solutions for building monitoring. They want to basically say, whenever my cooling system is starting to fail, then I want to send somebody immediately to fix it. I want to know very, very quickly when my cooling system is failing. So in order to do this, what they have sensors like temperature sensors all over this building. They have sensors in their cooling units and things like that. What they need to do is collect real-time information from these sensors, run rules or logic on top of this in order to detect anomalies, and then kick off business workflows from the results of these anomalies. That is where a stream processing solution comes into play. Because what they will do is, first of all, they will connect their sensors to the cloud and they will stream all the real-time data. And I believe data comes at frequency of a second from the thousands of sensors, right? Once they stream this data, then they need to have some place where they put the logic where out of these thousands of sensors, if one of the sensors cross a particular threshold, let's say 85 degrees, or I'm just making up this threshold, but I have one sensor which is crossing 85 degrees and it's staying sustained at that above 85 degrees for 5 minutes, right? They need some way to run this logic, which is on this continuous incoming stream of data. That is fundamentally what Azure Stream Analytics, or more importantly, a stream processing solution allows you to do. How can I run a query? How can I run a logic which is always running because data is always moving? It's unbounded data, right? And once I find this anomaly, I can take an action based on that. So the stream processing solution enables you to connect to this incoming source, run all of your logic, and then the result is piped to other sources. And I can get into more details of what people are doing, but hope this explains it.
Yeah, that's great. So let's take the Honeywell example and talk about the end-to-end flow. So you've got all this information coming off of sensors. Where does that information get routed to?
Perfect. So what Honeywell is doing is all of these sensors are connected to a single gateway or a set of gateways, which is their on-premise in their buildings. This gateway is streaming the data to a service called Azure Event Hubs. I believe you had a session with the folks from the Event Hubs earlier. Um, so once this data is streamed to Azure Event Hubs, then they have set up jobs or what we call logic that you're running on this incoming streaming data using Azure Stream Analytics. The result of these jobs goes into the outputs, and the outputs is dependent on what they want to do. For example, in one of their use cases, they want to do live monitoring of what is the real-time statistics of sensor information which is coming from my sensors. So they have a job in Stream Analytics, which does some aggregations over time, pushes the results to a real-time dashboard like Power BI. In cases where they want to be able to figure out what are the anomalies in the data which is coming, they have a job in Stream Analytics which looks at what are the thresholds being crossed by specific sensors, send the result to another event hub from where they have backend processes which kick off their business workflows. So that is basically the end-to-end which is created.
Okay, and let's go through some of the integration points in this workflow. So the information comes in, it gets aggregated or perhaps buffered at the point of the event hubs. And what happens next?
Great. So what Event Hubs allows you to do is Event Hub allows you to connect a bunch of readers to the incoming stream. One of the readers when a customer goes and creates a Stream Analytics job is Stream Analytics. So Stream Analytics is basically this process now which is running, which is saying, I know what logic you want to run. Let's get more specific, right? I cannot talk about the exact logic which the customer is saying, but let's say one of the logic they want to run is I want to get the average temperature over every 5 minutes and write it to a BI dashboard, right? So the logic which is running in Stream Analytics is the logic which computes the average temperature over these thousands of sensors which is coming every second and aggregates it in a 5-minute window. What happens is when the customer is sending this data to Event Hub, in real time, Stream Analytics pipelines read this data automatically from Event Hub, computes the logic where it's maintaining the state in order to actually compute the average temperature over a 5-minute window. And every 5 minutes, it writes the results to the output, such as Power BI. The real value here is, as a customer, what Honeywell had to do, all they did was write their logic. Everything else, things such as provisioning of the service, I don't have to care about setting up nodes. Automatically, we actually provision the service on behalf of the customer. The way I write my logic in a very simple SQL-like language. In order to write this computation of average temperature over 5 minutes, literally the customer wrote select average temperature from your input source, group by tumbling window of 5 minutes. That's like 5 lines of logic. And behind this logic, This is a query which always runs. Resiliency is built into the system. You can easily scale this out. We can talk about all of these aspects a little later in this call if you want. But hope this explains exactly what's going on.
Yeah, so would you describe this as a standing temporal query?
That's exactly what it is. It is a standing temporal query on data in motion.
What is data in motion? How would you define data in motion?
Data in motion, I would say, is any scenario where data is continuously being generated. And what you're trying to do is do computations on this data which is being generated before it is written to some store or written to some endpoint, right? So I am doing real-time computations on this data. So let me take a step back, right? I'll actually explain it in a very different way, data in motion versus data at rest. Let us assume there's a parking lot which a bunch of cars in that parking lot. Okay, the cars are parked. You want to ask a very simple question: how many red cars are in this parking lot? You have the cars parked. You can basically go and say select count star from parking lot where car colors equals red. The query runs on this data at rest or the cars at rest, gives you an answer, and then the query is completed, right? Now, let's ask the same question in a different scenario. Let's say you're standing at a particular point on a freeway and cars are continuously moving. You want to ask the same question, which is tell me the number of red cars which have crossed this point in the last 1 hour. What is happening is these cars are continuously moving. There's data in motion, and something is computing what is the count star of all the cars which have been crossing this point, and every hour it gives a result. That is fundamentally the difference between data at rest and data in motion.
So you have a standing temporal query from Stream Analytics sitting on top of an event hub. The event hub is throttling and buffering giant volumes of data, and the Stream Analytics can aggregate it into standing temporal queries. Give me an idea of some of the patterns that you can utilize with different technologies to take advantage of that standing temporal query.
Great question. The three common patterns that we see from customers, and generally many of our customers are in the IoT-like scenario, is I am getting the data from these sensors or devices, and I want to take this data and aggregate this information on a temporal window and create some kind of dashboards on top of it, right? So if I am a person who is doing process control engineering and I'm sitting in front of this dashboard to see what is the real-time statistics of my building, I can actually get that information immediately. Another pattern that we see is detecting issues in that incoming stream of data. So the companies like Honeywell or Aerocrine, another company I'll talk about later, what they are doing is they're again sending data from these sensors or devices. And what they are trying to say is, in case a condition happens, the condition can be anything like a particular property crosses a threshold, or in case of the Honeywell, they could do something like if the average temperature in the last 5 seconds was 20% greater than the average temperature in the previous 1 hour. So these are conditions or anomalies which happen. Then I want to take an action on top of it, right? So I detect this condition on this incoming stream of data, and I push the result to something like service bus, topic, queue, or another event hub in the output, like when that an anomaly has happened. So then a business process can be fit into that. The third pattern that we see very commonly is I take all of this incoming data which is coming through my stream, and I basically archive the data by augmenting this incoming data with certain information, right? So what I mean by this is we have a customer who is bringing in actually millions of IP addresses per day. Once this IP address comes in, they're actually doing some kind of an IP location mapping. So they augment each IP address with what is that location information which is there from an IP location mapping that they have. And then they archive the data in blobs. So then they can actually do some post-processing on top of it. Hope this explains those three very canonical patterns that we see. So it is hot, warm, and cold path analysis from that same stream.
So I want to get into the example where maybe you have this standing temporal query and something happens, like let's say the temperature. You're aggregating the temperature across the average temperature across a 5-minute rolling window, and that temperature passes 100 degrees, and you want to kick something off or pass a signal to a broader system. Would this be a case where you would want to kick off something in something like Storm, or kick off a machine learning process? What are some common larger scale workflows that you could kick off under certain conditions?
This is a great question. So everything depends on what is the business workflow that your business has. And a great example, you brought up the machine learning example, right? A thing which customers are doing is they are bringing in the sensor data. They are creating this temporal windows or anomalies that you detect on top of it. And then they are doing things such as, I want to be able to get a ticket in my service U account, correct? So they are basically connecting it to a complete third-party solution. For things additional to this, what they can do is they write this data to blobs and they run predictive maintenance models, machine learning models that enable them to learn what are the issues that could actually happen in future. Other things that customers are doing is, I actually am bringing this data in motion. We are actually in private preview on one of these features, and I want to be able to call a machine learning model on the fly on this data in motion to score it. And then I want to take some action after it. To be very, very, to give another example for this, for example, you can bring tweets from Twitter, and I want to get the sentiment for each of these tweets. Once I get the sentiment for the tweets, then I want to take an action on that. For example, if I get something like 100 tweets which have a negative sentiment in a 5-minute window, so I'm actually calling a machine learning model on this incoming data, and then I'm running a temporal query on the result of this machine learning model. Then I can basically kick off a business workflow, such as update my CRM saying a ticket needs to be created. Does that make sense how these things tie together?
So if I'm correct, what you're saying would be you have a Twitter fire hose connected to the Event Hub. You have the Event Hub feeding into a machine learning process, and you have Stream Analytics reading off of the machine learning process. And then, is that accurate?
No, it's just slightly different.
Okay.
Twitter host is connected to Event Hub. Stream Analytics job is created by the customer, where it is reading the tweets from that Event Hub. Then from within Stream Analytics, I am calling a machine learning process to get each of the tweets scored, get the result back into my Stream Analytics process, and run the temporal query on top of it. So within that Stream Analytics process, I'm not only getting the data, but I'm scoring the data with a machine learning model and running my temporal query to find the anomalies, right? That is fundamentally what you can do things like this in stream processing. Other things you can do is I can actually take a history of data, call a machine learning anomaly detection model. So anything that I want to do on top of this real-time data, I can actually do that using Stream Analytics.
So within this stack, are you saying that is Stream Analytics really like the lens that you want to look at your data through? You want to pull the data off of the Event Hub and read that data through the lens of Stream Analytics, or are there cases where you would want to pull data directly off of Event Hubs into a machine learning module or a Storm module?
This is great. Yes. So, and this is actually one of the powers of Azure. What Azure is providing is Stream Analytics is one of the first-party solutions that we are providing, which has all the resiliency and stuff that we'll talk about. But at the same time, if you want to take that same data and you want to call a machine learning model, you can actually do that as well. You can just write some custom logic which takes the data, run it on some VM or cloud services or something like that, calls a machine learning model, gets the results of it, and scores it. I can connect. Actually, we also have things like HDI, HD Insight Storm, and HD Insight Spark, which can connect to this same event hub and do processing on top of this, right? All of these, which I'm saying, where like Stream Analytics can connect to the same event hub, Storm can connect to the same event hub, Spark can connect to it, or I can write custom code which connects to this event hub. All of these are different ways for the customer to be able to customize their own workload, right? It depends on what is the skill set or what are the requirements of the customer that Azure is providing you this flexibility. An example is if you ask about what's the difference between HD Insight Storm or Storm workloads by itself and Stream Analytics. For example, if I am a company which already has an on-premise Storm topology, or I have a bunch of developers who are Java developers, I will basically can take my code, go to this HD Insight site and say, deploy a Storm topology for me, and I can take lift and shift my code to it, right? But if I'm a company who does not want to get a whole cluster and I basically have some small throughput jobs, I want to use the simplicity of a SQL-like language where I can do all of my temporal aggregations in 5 minutes in 5 lines of code. I will use something like Stream Analytics on top of it.
Okay, so I'd like to get a better idea of the integration between, like, when Stream Analytics is pulling data off of an event hub. We did do a show about event hubs recently, to talk about it, to hear about event hubs. But from the Stream Analytics point of view, what is going on under the hood when obviously from the user's point of view, the user is just writing some standing temporal query that is aggregating, for example, a 5-minute rolling window of the information. But obviously under the hood, there's a lot more complexity going on. So what kinds of things are going on under the hood?
That's a great question. So let's take a step back and say, if I want to actually run a temporal query like what you had mentioned, what are the things I need to do, right? One, I need to have a service which is able to connect all the time to this ingress source, which is Event Hub, and continuously pull this data which is coming to Event Hub, right? So real time, I'm pulling the data as soon as it's sent to Event Hub, it comes into my service. Second, I need to have things such as the ability to scale up or scale down the service. Third, I need to build things like resiliency into the service. We talked about a 5-minute window. Imagine you had a 1-hour window, and we all know machines crash, things happen. You have to build recovery into this system. I need to be able to do things such as ordering the events in a particular order. These are all the things that a developer needs to do, including management and deployment and things, when you go and try to set up a streaming solution. Only after you do these things are you actually, or writing the logic is just a part of doing these things, right? What Stream Analytics enables you to do, it is a fully managed PaaS solution, platform as a service solution, where we actually take care of everything from deploying the service for you, building in resiliency into this, doing this, helping you with the scaling of this, and also like things like reordering of events, which is very important for temporal use cases. The only thing we want your developers to do is come and write your temporal logic in a simple SQL-like language, right? The thing which I talked about, the tweet being scored, correct? Where I take data which is coming from Twitter and I score it with a machine learning model, and then I push it to a BI dashboard which shows my real-time analytics. The only thing I wrote to do that was one line of SQL. Select like text, which is basically coming from my Twitter, sentiment of text, sentiment calls the machine learning model, and write it to a BI dashboard. So now think about the advantage that my developer has. What we are going is, I mean, success for me, for a customer who is using Stream Analytics, is I am able to set up my streaming pipeline in a day.
Yeah.
Actually, I want to say in 10 minutes, but I'm just going to be modest and I'll say a day because you have to do other things as well. But if you have to write a line of SQL, it doesn't take that long. It is removing those complexities of doing temporal processing and putting it. And when I say the SQL, what we did is we basically took those parts of SQLs like projections, aggregations, functions. We added temporal nature to it. We gave new functions such as hopping windows, sliding windows, tumbling windows. And basically, we took those SQL semantics and put it on top of our stream processing solution, right? Um, so hope that explains what I'm trying to say.
Yeah, no, absolutely. And I think the SQL discussion is interesting because when we think of SQL, we tend to think of how do we write a query that is going to assess a large volume of just data in a database. What changes when we think about how are we querying this moving data? Because conceptually, an event hub that is constantly being updated with new information and buffering that information, that seems somewhat different. So if we're thinking about writing efficient queries, or even just the types of queries that we could write, which could potentially be joining different event hubs as if they're database tables, what are some things that we need to keep in mind?
The most important thing I would say, I mean, having been in the space for some time now and talked to a bunch of different customers, is this temporal data which comes into the system or data which is coming into Event Hub. The temporal nature of it is very, very, very important. Events which are pushed either to Event Hub have time which is associated in the payload of the event which is pushed. There is time associated on when that event reaches Event Hub. There is time associated with what is the order of events that it is coming into the system, right? So understanding like what a stream processing solution really does is it takes a stream of data and gives you a resultant stream of data, right? When I'm doing an aggregate over a window, at that particular point of a window, I'm writing a new stream. Every 5 minutes, for example, I'm writing a new data result. When I'm basically saying I want to detect an anomaly, where this anomaly can be detected every second or it could be detected once every day, taking an incoming stream, I'm running some logic, and my output stream is coming. Everything that I mentioned to you has a temporal nature which is embedded in it. And the temporal nature starts with the event which is being pushed to Event Hub or IoT Hub, and we can talk about that later, or my ingress mechanism. So whenever you're writing a temporal query or whenever you're writing a stream processing query, understanding what timestamp you want to use for that query is a very important aspect. An example I will give you is from one of our customers. We added a functionality into the system. What this system does is because thousands of sensors from a building can be connected to a gateway, and this gateway is sending the data to Event Hub, you never have consistency on when a sensor is actually sending that data to the gateway, right? So some sensors might be sending it much faster than other sensors, but each reading has a timestamp associated with it. In order to find things such as patterns in the data or aggregations over time or anything in the temporal nature, the first thing you want to do is you want to reorder those events and make sure all of these thousands of sensor readings which is coming is ordered by a particular timestamp. And then I run my logic on top of it, right? So you'll have to start thinking about how do I deal with this concept of time before I do a stream processing logic. It's one of the main things that we have seen. The other things that you have to do is you really have to figure out what is that logic that I want to write, right? Not everything is on the basis of time, but most of them are on the basis of this timestamp which is associated with the payload. So how fast do I want my logic to be? Am I taking multiple streams of data and I'm joining them together? Am I trying to find patterns or the lack of patterns in this data? How do I think about doing management of state? And when I say state, it is state within the temporal query that I'm running. So these are things that I have to think about when I write a stream processing logic. And any platform as a service solution, like you have other things, a customer, I mean, what I'm saying, a customer can go and do all of these things in Java or C Sharp by custom coding this whole thing, right? But when you're providing this platform as a service thing, what is that least amount of thing that you make a customer think about? How do I scale up? How do I scale down? Things like this you need to actually provide in a stream processing solution.
Okay, so as we're talking about the issue of time, I think it's worth talking about the issue of latency. Um, if we have a Stream Analytics standing query on top of an event hub, event for listeners who are more familiar with Kafka, it's just like Kafka, it's massive stream of data that's coming in, and this Stream Analytics, if you're doing something like joining across two event hubs, it could be a potentially time-consuming query. It's not just like a magical constant time filter. So, what kinds of latency should users expect for a complex query, complex stream analytics query? Because this query is going to be delivered potentially to somebody on Power BI or on Excel who is maybe looking at a dashboard and interpreting that dashboard as being real time when in fact there is some degree of latency.
No, that's a great question. So let me actually explain a little more about the internal details of the system, right? One of the things that the two knobs that we give to the customer, or actually more importantly, the single knob in this particular case that you want to think about, is a concept of a streaming unit. When you go and set up a stream analytics query, you set up, say, how many streaming units do you want for the query? Okay. A streaming unit is fundamentally the amount of processing power that you give to that particular query. So we have a scale tab. If you go to the scale tab, you can select how many streaming units I want. Now, in order to determine how many streaming units you need to give or how much processing power you need to give for your query, it really depends upon what is that query you're running. So let me give you some basic examples. If I am doing some basic filtering, like I only want on signals and I don't want to store off signals, this is a very basic thing, or I only want to aggregate the data in some 1 second window, right? What we say and what we measure is for 1 megabyte of second that you're pushing through the system, we will process that data within a second. So it is real time that you get the data. So I believe Event Hub, and please do not hold me to this, but Event Hub basically says things such as from when you push the data to Event Hub to when a reader like Stream Analytics can read to that, that's a maximum of 100 millisecond latency, right? What we say is if you push a megabyte into Event Hub to when you do your processing and these basic queries that I'm talking to you about, which is aggregations, filtering, so just pass through, it will be done within that second, right? And then you can get the result. So less than a second latency for this happening within a megabyte per streaming unit. Now, once you start adding complexity into the system, into the query, where let's take your query and put it in a real example. I have two streams coming in. I want to be able to join these two streams on a particular field, and I want to have this field to be in a window of a minute. So just to be more accurate, we had a customer who basically bought two Twitter feeds together, and their logic was something like, if a user on a particular topic changes their sentiment from positive to negative or negative to positive within 1 minute, I want to know who is the user and who is the topic. What is the topic from a set of topics? This seems arbitrarily complicated because you're pulling in multiple streams. You're basically checking every tweet which is coming in with every other tweet in a 1 minute window to see are the users and the topics the same and when the sentiment has been flipped in that minute, right? When you go into such complex queries, and the more complexity you add to the queries, you need to look at what is the amount of processing power which is being used in your system by the SUs that you have selected. What we have done is we have given you some metrics and dashboards which tells you how much processing memory and resources is being used for your stream analytics query. Once you cross 80%, we recommend that you actually increase the streaming units that you give to that query. And one other thing I want to add, I'm talking about 1 megabyte per second, right? I just want to quantify what that 1 megabyte per second actually means. And I'll quantify it through a real life example. Have you heard of this website which went viral last year in May, I think, called howold.net? This was basically.
Yeah, this was the Microsoft thing.
Exactly. Actually, one of my colleagues and I actually built this thing because Stream Analytics was GAing. So this was built for showcasing how you do real-time processing on Azure, along with some perceptual APIs and things like that. So just to let you know what scale it hit 50 million users within like 5 or 6 days. So faster than Angry Birds, just to be honest. At its max, it was having 1.2 million users who were saying, hey, look at this photo and tell me what is my age and gender, right? So what we were doing, just to go into the internals of that, because it will help with understanding what happens, is when you uploaded a picture or when you selected a picture, there was some code which was running, which basically called the perceptual APIs, which is the Oxford APIs, the machine learning part of things, which said what is the age or gender of the face which was detected. We basically did not store any of the photos. All we said is this age and gender comes, we wrap it in a JSON payload with your web statistics, like web server logs, and we send it to Event Hub. So every time anybody went to their web page, selected a picture, all it did was age, gender of the face detected, which is sent as a JSON payload. At its max, with 1.2 million users per hour, we were sending 9 gigs of data every hour through the Event Hub. This was less than 3 megabytes per second. Right? So now you can start seeing that it is the scale that I'm talking about is not just about the number of events, but it's a number of events plus the size of the payload. The customer I mentioned who is bringing in IP addresses is bringing in around 9,000 IP addresses per second. It is less than 1 megabyte per second. So now you can start thinking about how I need to scale up. It is number of events plus the size of the event that I need to think about. Okay. And we should also talk about costs if you're interested.
Yes, let's talk about costs a little closer to the end. So yeah. I wanted to talk about a little more of the application side of things. So
sure.
I'm obviously gonna do a show with your colleague about this. I think Assad, the managed Insight HD Insight Storm or Spark story. So how do Storm and Spark fit into this conversation? Obviously, you are on the Stream Analytics side of things, but I assume you know some about the use cases. We've done a lot of shows about Spark, so I'm curious how you're seeing, I guess, from customers, what customers want out of Spark and perhaps out of Storm.
Yeah, no, this is important because just to be very blunt, this is exactly why in Azure we are not only saying we have Stream Analytics, but also we are saying that we have our own managed Storm, we have our own managed Spark. Customers can come and use our IaaS for doing Storm and Spark, right? It just goes down to use cases. It goes down to how much throughput I'm bringing to the system. It goes down to what is the developer capabilities that we want to bring into the system. And these are the things that go into the decision making on what system that you select. For example, in Storm, I can write my code in Java, in .NET. I have to manage some of my topologies. The resiliency, I like to figure out how to actually write code for that. There's a bunch of things that I can do. It is very flexible, but I need those kinds of developers who can write that code, right? We did some compete studies through a complete external company, and we noticed that what took 5 lines of SQL, and not like everything was written in one line. It took hundreds of lines of writing that same code in Java, right? And and it's not like it cannot be done, but it again comes back into how can I manage it very easily. Now the other thing that you have to think about, when I get Storm, I'm getting a cluster, right? And so what is that cost? That's why I mentioned a little bit about cost. What is that cost that I'm actually paying for that cluster versus something like Stream Analytics? I am basically paying for usage for throughput per SU is how we actually charge this, right? So for my low throughput workloads, I actually pay only as per I use. I don't have to buy a whole cluster for my maximum throughput usage, and then only pay for the whole cluster. Uh, the other thing is things such as the reordering of events, the resiliency. So we actually automatically checkpoint for you internally, so you get the fastest recovery. Things like this needs to be coded in some of the Storm topologies, right? Now, even Spark is coming out with Spark Streaming and Scala and other things. But again, if you take a step back and look at what can be done with the SQL part of things versus what is done with the Scala part of things, right? You have that flexibility. You go and ask the developer, what are you most comfortable with? Things like, if I want to use the application payloads timestamp, right, which is basically the timestamp of not when the data came into Kafka or Event Hub, but the timestamp of when it was generated in the device. In something like Stream Analytics, all I have to do is we have given you ways such as timestamp by the timestamp that you want to use. And all the aggregations are now done on this timestamp of the device and not when it comes into the system. In something like Spark, you might have to write the code and build it into the system.
So you're talking about this kind of trade-off between, in Stream Analytics, you have a SQL, which is essentially like a domain-specific language that makes it easier, perhaps puts some restrictions on the types of things that you can do, but the types of things that you can do are made really easy, or at least less verbose than they would be in Storm or Spark.
Exactly. And the other aspect for this is, even though it's a declarative SQL language, if you see some of the things that we have done with the machine learning integration, right? What we have done is we have allowed you within your stream processing query for calling that sentiment or that anomaly detection, we allow you to call a machine learning model which is hosted somewhere else. So this is a web service call that we do to a machine learning model. So I can write my custom code, host it in this machine learning endpoint. Our first integration has been with the machine learning endpoint. We are looking into how do we extend it to other places where I'm running my custom code. Under NDA, I can't talk about that right now. But if I have some arbitrary Python or R code, I can basically go to Azure Machine Learning, write my arbitrary code, operationalize my endpoint, and then I can call that endpoint from within my SQL by creating what is called a user-defined function to that endpoint, right? So you can get that flexibility by hosting it somewhere else.
Okay, so let's talk a little bit more about cost. Obviously, when people hear the term managed, I think the first thing that they think is this costs money, and that's obviously true. Platform as a service, it's an addition. It's going to be an additional cost on top of what would be the cost of an infrastructure as a service, with perhaps some roll your own solution on top of that infrastructure. But of course, oftentimes the platform as a service, like this managed Stream Analytics, this managed platform that Azure can provide, you can oftentimes save time, and time is obviously money. So there is a sense of trade-offs here. So talk some about the costs of these platforms.
Perfect. One of the main core tenets that we went after when we built Azure Stream Analytics was, one, developer productivity. We want developers to set up their pipeline faster than anything else, right? That's why we did the language. The second thing that we realized was, in streaming scenarios, the throughput is very variable. We have some customers, big customers, who are bringing in 2.5 terabytes of data every day, but that's around 30 megabytes per second. So we ended up building a multi-tenant solution. So if I am doing 1 megabyte per second processing continuously, you basically pay $25 a month. Because we built a multi-tenant solution, we were able to build one of the cheapest stream processing solutions in the world right now. So when I talked about Honeywell.net, right? And Honeywell.net bought 9 gigs of data at its max. If we were having 9 gigs of data continuously flowing through the whole month, because I was just doing a basic aggregation query on Honeywell.net, I had only one SU that I needed to use. Actually, for Honeywell.net, I used 3 SUs. For using 3 SUs for the whole month, it would have actually costed me $75 a month. Imagine doing a fully managed solution which has everything from resiliency, which is built in, to ordering, which is being built in, to ability to use different timestamps, to the ability to scale up and down very easily. And all you're doing is writing your query in SQL. You basically pay $25 per month for doing 1 megabyte per second processing on one SU. Uh, I will tell you this. I have gone for dinners where I have paid more than $75 a month just between me and my wife. Uh, and imagine running something at the scale of Howl.net at its max through that system. That's why I kept on saying, like, it really comes down to what your customer wants to do.
Okay, that's very interesting. So I'd like to zoom out some and talk about the Azure platform as a whole and where things are going. As I've been doing different shows with people from different cloud service providers or people who are familiar with different cloud service providers, people who have used AWS or DigitalOcean or Azure, the story that I seem to get is that cloud is so big, it's such a big shift that there are all these different pockets of micro markets. So it's not like this winner take all market where one company is going to win the entire cloud business. It's going to dominate the entire cloud business. One size fits all for cloud computing. Give me an idea of how you see the cloud infrastructure and platform as a service market evolving, and what is Azure's place in it?
So, I mean, this is great. Actually, I have been. I'll give you a little bit of background too. Before I came to work on Stream Analytics, I actually worked in MSR and SQL product. So released some box products, which is called Always On, which is the high availability solution from SQL Server, right? What I have noticed from just the customers that I used to speak 4 years back when I released Always On to now, I'm seeing the tendency of these customers to say, I am more open to move my workloads to the cloud, right? So what is happening is people are seeing the advantage of not having to manage my own data center, not having to manage my own resources, and when I say resources, I actually mean hardware resources, more importantly, the people resources in order to manage your assets, right? The value benefit of this is coming up so much more right now that people are more open to come to the cloud. And when they're coming to the cloud, they're coming to a bunch of different use cases. I mean, to be honest, I know the IoT and the analytics use cases a lot better because this is the world that I'm ingrained in, given my SQL background. But I mean, if you look at how easy it is for me to sit in my house and I want to launch a web page for my brother actually asked me this a few weeks back, and he's like, dude, I want to just launch this web page for something personal that he's doing. I literally was sitting in my house while I was on the phone with him, and I just went to the portal and said, all right, here it is. Now you have a web server which is already hosted, right? And then I just put the bits on it. So it's not just these companies, but there's a shift in how do people start doing business. Then there is another shift which is happening with IoT and devices which are actually cloud connected devices where the data is being generated in the cloud by itself, right? So all of these things are moving and shifting towards bringing data, making it easier to bring data to the cloud, doing more compute on the cloud. And this is where the whole cloud market is exploding. And this is where, if you look at what companies which are dealing with this market, what they're doing is they're investing equally in different parts of it. They're investing in compute resources. We are investing in storage resources, right? I mean, good example is Microsoft came out with Blob Store, then they had Table Store. We're computing in more and more data management platform resources. Great examples are things like you can actually go to, and I can talk more about Azure, but I'll talk about a little bit of history. I can go to Azure and I can provision things like MongoDB on IaaS boxes, but at the same time, we will come out with first party services like DocDB, which gives you a lot more performance and efficiency on top of it, right? So you not only have first party things which give you efficiency, resourcing, things like DocDB, Stream Analytics that I said, but you can also bring your own solutions and lift and shift to the cloud and help resources. So the combination of what we are doing with infrastructure as a service, compute resources, data platforms, analytics platforms that we are building is really making it easy and giving the flexibility of customers to bring their whole solution or parts of their solution to the cloud. The other thing which is happening is people are realizing that, hey, a lot of data is really being generated and there's a bunch of different analytics I want to run on this data. How can I use the flexibility of cloud solutions in order to do analytics on demand for me, right? Stream Analytics is one of those things, right? I want to do real-time analytics, but I want to do it only on 3 megabytes per second. So I just want to pay my $75 per month. Or I want to be able to start up a SQL data warehouse and use the resources of that SQL data warehouse only when I actually need to run my job once every day. And I don't want to pay for any other time for it. So these are those flexibilities that cloud service providers have to start thinking about more and more. And cobble this with the more you make it easier to bring data to the cloud and do analytics, now you have to start thinking about user experiences. So the more we do with things like machine learning, where we give you studios, where even people like me, who actually I don't know much about machine learning, just because I'm a part of this machine learning organization, I've learned a little bit. But if I want to do my sentiment analytics, or if I want to do some anomaly detection, there are APIs which are available in a marketplace where I can really get it easily and do it as a data developer in the workflow of what I do, right? So those are some of the things that we have to think about when we build a platform. And it always comes into the end-to-end use cases. I'll give you a very off-the-cuff example, right? We have, from streaming, one of the use cases that customers want is, hey, when I detect an issue, whether this issue is over social data or sensor data or service data, I want to get a text or an email from it. We kept on thinking, we were like, dude, should we go and build an output to Twilio so you can get a text message? Or should we build an output to some SMTP server so it could actually send mails and things? But then what happened was we talked to another team, which is called, there's a service which came up on Azure Cloud called Logic Apps. Logic Apps allows you to build your business workflows in the cloud. So all we had to do is we had to figure out ways to tie these two pipelines together. So now I can bring in streaming data to Event Hub, do my real-time analytics using Stream Analytics, write the result to something called a service bus queue, which is now picked up by Logic Apps, and it can send an email, it can send a bunch of different things. So that flexibility provided by this set of services is something that you have to think about.
That's interesting. Not to open a can of worms, but it sounds like the future in your perspective is kind of a polyglot cloud with like multiple, you're not just using one cloud as a walled garden. You're using multiple cloud services and paying multiple cloud providers.
Well, what I'm saying is I'm actually separating this cloud providers from the services.
Oh, okay.
What I'm saying is a true successful cloud provider will give the set of services which will enable a customer scenario to be completed, right? So as I talked about the logic apps, stream analytics, machine learning, well, I don't care. I mean, I'll just bring up a bunch of different things. I can throw names, but it is more about what is that business use case, which cloud provider can provide the SLAs for these business use case and help me stitch this together, right? One of the things I would love for us to do more, and actually what we ended up doing with the IoT suite solution that we gave out. So with the where the world is moving a little more, like moving from just PaaS services to SaaS services that we sell, right? Uh, I don't want you going and saying, I want to do device management. So go set up your IoT Hub, Stream Analytics, DocDB, blah, 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 like 20,000 other services. What I want to give you is a single button that you press, and all you see is all your devices connected. You see your live dashboards in the end. You see your Logic app accounts in the end, right? So I would see more in the future things moving from these individual services to solutions which are being sold, which is a composition of these services to complete a use case.
Fascinating. Well, Santosh, that sounds like a good place to stop. This has been a super interesting conversation, and I look forward to continuing to talk to your Microsoft colleagues to get a better picture of the Azure stack and where things are going.
Thank you very much. This was very entertaining. Hope the audience enjoys this as well.